Please welcome Anja Moldehn.
Yes, thanks a lot for welcome here. Thanks a lot for your time that you take today to listen to some things about Industry 4.0. Yes, as we have heard from Jack in the morning already, it's about exploration before conquering something. So I would like to give you more information so you have a better exploration. So today I would like to give you insights about digitalization, what are challenges that we are facing today, and I would talk about why it's a worldwide topic. So I know Industry 4.0, it's a German word, but it's a topic for the whole world, of course. I will give you some information about technical basics, and of course, most of all interesting for you as an example is building IoT to understand a little bit how these basics work in the real life. And for you to understand that we are as Phoenix Contact only as an example to show what may happen, I will give you an insight about how our company started this so-called digital transformation. So maybe with this you have an idea how you can go forward with these topics. So first of all, let's have a look into history. So what you see here, it's based on production. So we see mainly four big changes. This is why we call it Industry 4.0, because we see it's the fourth big change that has already started. So it was mechanical production, workpiece production, PLC-based automation. And what we see already started today is the intelligent networked automation. I think with this picture you can really good understand that it's a process. It's nothing that happens. It's something that happened all over the years, because if we have new technologies, of course we implement them. Doesn't matter in production lines or building or what applications soever. So what is possible will be done, of course. Important also today is that this intelligent network automation is the first big change that we can change altogether. So it's the first time where not an industry tells us what to do, or that we know, okay, PLC-based automation is a hot topic, we have to take care. The Industry 4.0 or IoT thing is the first time where the humans, we all are working at those companies, have the possibility to change something. So it's nothing what is ready, where we know what it looks like in 20 years or 30 years. It's our time here now to think of the future so we can create the future by ourselves. And this is a real nice possibility to start with, I think. So nothing to be afraid of, but really a nice possibility to change our world and maybe the world for our children. And of course, this already started. I've already mentioned this word Industry 4.0. So it's a word created from the German government to show our German companies that it's really highly important, that you have to take care about it if you want to be successful with your business also in future. So this is only a name, Industry 4.0. Here in the US, you have the Industrial Internet Consortium. We'll come to that a little bit later. Maybe you have heard of China Manufacturing 2025. It's more or less the same like Industry 4.0. So there are many, many words all over the world. Each country nearly has its own name for it. It's not perfectly the same, but it all addresses digitalization. So let's see how it affects us all. So of course this word Industry 4.0 means everything about production. But as we have heard the whole day, digitalization affects all our surroundings, our private lives. It's from infrastructure, energy systems, it's about machines and plants, power generation, whatever. So I think this is something what we have understood already today. Somehow everything will grow together with this digitalization. Industry 4.0 covers only a small part of this. So the word itself stands for digitalization of production and product lifecycle. It's about technical integration of cyber-physical systems. We have heard this word before, but I will explain to you in detail what a cyber-physical system really means. It's about Internet of Things and services, and when it comes to Industry 4.0, it's always meant for production and logistics. Here in this picture, you see that Industry 4.0 is maybe only a part of digitalization, but it's connected. So there are connections to smart building, to smart grid. So again, here everything is growing somehow together with this digital stuff. And of course, it stands for new possibilities to earn money. Very important thing when it comes to money. What can I do with this data? I have lots of data. I know lots of things. I can do algorithms, artificial intelligence, everything very exciting. But of course, we all want to earn money, so I have to think about new business models. And today, I would like to show you what does this mean, cyber-physical system, and how can it grow together? How do we do that already? And I want to give you an example from building IoT, what possibilities for new business models are available right now. So it's really international. So when you think of the internet, internet will only work if everyone uses the same communication, if everyone can be connected to each other. So it doesn't make sense to make Industry 4.0 in Germany or to make it in Europe. So it only becomes a truth in our surrounding when we make it really international. So the communication must be really the same all over the world. And yeah, it sounds complicated, and I think it is complicated really. And it took us a pretty long time to start some kind of cooperation. So when it comes to details, there are only two big communication models that are interesting for this worldwide communication. And this is the one from your Industrial Internet Consortium and the one from our Industry 4.0 platform, as we call it. They have two different points of viewing at this topic, digitalization. So your IIC here is of course also global non-profit organization. That's the same also in Germany here. You see, when you started in March 2014, we started in April 13. So it's both from politics, from the government, it's from university science, academia, it's from industry. So far, both ideas started from the same point of view. But in the US, there is a different approach. So it's more based on your Internet of Things idea, Internet of Things and services. So it's about cross-domain oriented approach. So in comparison to this, this platform Industry 4.0 really focuses on the trends in production. So it's really the digitalization in manufacturing. So it's not completely different, but two different points of view to this topic, digitalization. And when it comes to worldwide communication, of course, it's very important that we speak the same language, let's say. So for me as a German speaker, it's not so easy to speak English all the time. And this is very important that our digital products, our cyber physical systems can speak the same language all over the world. It's not very easy, but it is done already. Because for these two big ideas that are on the world available, we have two different models for communication. As you see here in the picture, yeah, it looks complicated. I think if you go into detail, it is really complicated, but usually you do not have to understand it in each detail. Important is to understand that they offer a basis. The basis for a consistent and for a reliable communication framework for all over the world. And in this industrial internet reference architecture, what is the model here from the IIC, you have standards for industrial Internet of Things. That means every company, every person who wants to create cyber physical system, wants to create a software, wants to create a new product, which is part of IoT, has the possibility to look into this model and to understand where this product needs to communicate. So I, for example, know what communication basis is necessary for our power supply unit, for example. So it's a common architecture framework. It's necessary if you want to communicate in your IoT world. Then there is a second model. We call it Reference Architecture Model for Industry 4.0, RAMI 4.0. So this also offers a guidance. It's focused on industry, so it's focused on production. So more or less it's the same idea behind. It's a model for communication, but really only with focus for production. So in 2015, it was first time where both organizations sent people taking care about these models to talk to another. So first of all, of course, they had to understand what is the idea of the other architecture model, what do they want to achieve with it, and understand really the perspective, why it was done like this. They worked for several years, and this year we see an ongoing approach for interoperability. On this year Hannover Fair, they stood there together and talked about what they are doing and why and where are the advantages for a company. So they identified mappings, they identified differences, They formulated all requirements, what had to become easier. And the big advantage is that you see here, this is the model for Industry 4.0. This is the model for IoT communication. They found the possibility to exchange information. So where an IoT system needs information from the cabinet, so you can imagine machine, cabinet, there are interfaces in there, there are power supply units, batteries in there. You need information from this cabinet out of this model, and you want to use it for preventive maintenance, for example. You need it in this communication model. So this is already done. So it is today possible to connect these models, and it's clear for those people who do the programming how they can change information. So very important step into this worldwide communication. Otherwise it will not work, but that's not the future. This is already done and working. The German platform Industry 4.0, as I already said, is from industry, from science, and from politics. We see different parts here. It's for expertise, governance, international corporations, where they work together with the IIRA, of course. It's about implementation, so like labs, networks, everything. So this is their main structure. For Phoenix Contact, it's very important to understand what is happening there, what is happening, and to work on standards, because all this structure in this German platform, Industry 4.0, is meant to offer standards. So without any communication standard, there will be no global communication, of course. And this is why we started pretty early to work in this German platform. Our Mr. Roland Benz, CTO from Phoenix Contact, is working in the steering body here, so he knows about the strategic development, and he can focus on those topics that are most important for us as a producing company. And we have many people working in these working groups. So you find these working groups here in this expertise group. So we are part of reference architecture and standards. Means for us, we are producing products for the cabinet. So we need to know and we need to learn how our products can be part of this Industry 4.0 network. So for this, we are working together with many, many other people at this reference architecture model. We are in the research and innovation group. Security is a hot topic, so we have specialists there working in this security group. So always not only to learn, but also to focus on things and to help making new standards for the security of industrial products. We are working with this regulatory framework, and also people, humans, are very, very important, because without all of us working with this networking stuff, IoT will not happen. And therefore, labor, training, education, we are also in there to focus also on how we can make it real and how we can not make it real in a technical way, but also how we can take all our people with us together. Because we are sure that it's not a matter of management. So of course, the management will have best ideas what can be next or how we can earn money in future maybe, but the knowledge is directly at the people. So it's decentralized. If I'm product manager for power supplies, I know exactly what my customer needs are. I know exactly what I can do better when I use digitalization in my power supply. And this is where we are sure that we have to take all the people together walking this way to digitalization or to the digital transformation of Phoenix Contact. So this is why we are in all of these working groups to understand and to create standards. Now let's have a short look into the basic stuff. We have heard about this standard communication. There is a standard language for exchange communication. This is where we use this communication models. And I, of course, want an easy installation, easy operation for my IoT or Industry 4.0 systems. This is all the same. It doesn't matter if it's from infrastructure, if it's for producing, if it's for oil and gas industry. So the idea behind is for all those digitalization stuff, always the same. We have heard of this cyber physical system. I want to talk a little bit about that because this is the basis you need definitely to connect the physical world to the cyber world, to the virtual world. So we have heard today lots of things about that we have to connect, that we get data, that we integrate physical things into a system, and this must happen somehow. And this is where we find a cyber physical system. A cyber physical system is a possibility to make a physical thing like this, what I have here in my hand, to become it a virtual element. So cyber physical system always means I have a part with it physical and one part with which is virtual. And when I have this virtual and physical world matched together, I need communication. And then I have cyber physical system. So this is a little bit for understanding. So I have physical objects of some way, like sensing data with sensors. I have actuators maybe. Then I add a little intelligence. So I have a control here. I'm on PLC level. And when I then add a machine-to-machine communication, a link between machine and human being, and link to the internet or some other kind of communication system, then I can communicate, I can interact. Then this is what I call a cyber physical system. And to use these worldwide for data or use the data for services, I need then an address, and then I'm in the Internet of Things. You have seen this picture on the first slides. This is our communication model for Industry 4.0. Now, how does it come that we can have a thing, a physical thing, communicating with this model? So this is where this cyber physical system comes into life. So you can find it in brochures and books. It's referenced as Industry 4.0 component. You find it as digital twin. You find it as cyber physical system. It means always the same. So it means always that I have an object, that I have a virtual part that describes the object, and this is somehow located here in this model for communication. You see here it's a three-dimension object, and I would like to show you what these three dimensions are about. So it's like a map, a three-dimensional map, which shows Industry 4.0 in a structured manner. So I can understand where I am, where a product is, and how this product can communicate to the internet, to a controller, to SAP system, to a human being, whatever you like it. It's necessary, of course, that with this model, this reference architecture model for Industry 4.0, that all parties that are involved understand each other. Otherwise, it will not work, of course. So let's have a short look on this slide. You have seen this in the beginning also. Jack showed us this one to explain how communication will change. So most of you know this pyramid for communication that we use right now. And this is where we want to be. So everything is intelligent in some way and everything can communicate in some way. But how does it work? We know really how this works. For this pyramid, this structure, I know where my product is. It's isolated. But when I have information from a field device, I can communicate to the control device. I can give information, if necessary, up to enterprise system. And, of course, all the way down if necessary. This is how we work today. So this is Industry 3.0. With Industry 4.0, I'm much more flexible. So I can distribute functions throughout the network. So you have heard already about that when we've heard that batteries, thousands of batteries become an energy storage which is needed, which is used when I need it. So this is also a hot topic here for Industry 4.0. Everyone can communicate with everyone, so it doesn't matter in which hierarchy level a product or controller or even an enterprise system is. Communication all over all participants, so really from a smart factory, what is meant here, to smart products all over the world, everything is possible. And this is possible with this architecture also here. Here we have communication from business over asset, data, down to the physical object in the real world. This is one of the axes. First axis is what we have seen in this pyramid, this flexible pyramid that changes. And third axis is the product itself. Because with Industry 4.0, I need to have the possibility to show the product life cycle. So life cycle for us at Phoenix Contact means someone is thinking of the product, is designing it virtually. At the next step, I have the construction plan here. Then I go to production itself, so the real hardware is produced. But at the end, there is service, maintenance, recycling maybe, or someday I throw it away. So from the first idea how a product may look like until I throw it away someday, I have the possibility in this communication model to locate my product, to get information, and to put information in my product again. So this is the communication model. But the model for communication, of course, is not enough. I need the possibility that the product itself can communicate. It's always a funny question when it comes to products that are not intelligent. The question very often is, okay, I'm not responsible for Industry 4.0 because all my products have no computer integrated. I have no Ethernet communication with it. There's no USB stick. So Industry 4.0 doesn't matter to me. But that's wrong, because this is where the cyber-physical system comes into view. If I have a terminal block, of course, the idea of Industry 4.0 is not to produce terminal blocks with some kind of Ethernet connection or whatever. Of course not. But I want the possibility that I can that I can access this terminal block, for example. Maybe I want to know where have I bought it? Is it from Phoenix Contact? Is it from another company? Maybe I open the cabinet and I want to get 10 more of these perfect terminal blocks. Then I want to order it individually. Or if you think of interface modules or power supply units, I want to know how old are they, what is the article number, what was about test reports, is the product itself okay or not, whatever. So I want access. And this is access, or this communication is done with this cyber physical system, with this digital twin, or the word is also administration shell. So this administration shell, or I always prefer the word digital twin because I think it describes it a little bit better. The digital twin connects the physical and virtual world. So with this digital twin, I have a data storage. It doesn't matter where it is, so it has to be somewhere near the physical object. It's somewhere on my server or somewhere in the cloud, but I have a data storage available for this terminal block. And there I have all information available. It serves as network standardized communication interface. So this is what we call this digital twin. You see this picture again, this communication model, and this digital twin again. So this is the physical thing, and I have this digital twin available somewhere in the cloud, somewhere on the server. What I have to do is to connect the physical object to this digital twin itself. So this can be done, for example, with a QR code, with a serial number. So I need to identify my physical object, but that is enough. So if I can identify it, I can communicate with it. I can collect data in this shell. And this is where all the advantages come from, because I know about a product. I have data storage for this product over the whole life cycle. And this is what is meant by life cycle. So this picture shows us that information, that data of a product is growing. So if you think of a DNA of a product itself, it starts when, for example, we as Phoenix Contact buy something from a supplier, maybe plastic parts, diodes, resistors, whatever. So we start collecting information in this digital twin. Then we add everything what we do. What kind of material is it? How is it produced? Is there a firmware on this product? We add all this information to this digital twin, so I have everything stored in this digital data storage. And then at this point, our product is finished. So we now sell it to our customer, for example, the terminal block or the power supply. And then the customer takes also this digital twin and he lets it grow also. So he can put information in, okay, it's cabinet number 25 where I now integrated this power supply. I want to sell it to my own customer. Then it goes to the, I don't know, it's shipped to China and it's integrated in a big, in a bigger application somewhere. This is all information I can add here. Here you see what we at Phoenix Contact do for this digital twin. So we first of all put things in it, like data sheet, order numbers, 3D models, engineering information. When I start producing it, it gets the serial number, special product information. This is all data that is stored in this digital twin. Additionally, I have this digital twin available for information during the process. So it's not only data, fixed data, static data that you see here, but I also see data in this digital twin when it comes to the usage. So for example, if I have an interface module, I get the information about data out of the interface module. Or if I have a switch, I can count in this digital twin how often this switch is going on and off, or relay module. So all this dynamic data out of an operation is also available now here in this digital twin. And this is where we focus on when it comes to earning money, for example, because when I have all this information here, I can access them and use these data for artificial intelligence, for predictive maintenance, whatever I may think of. This really depends on the application itself, but I have everything I need from the data available in this digital twin. So with these cyber-physical systems, I have lots of possibilities that were not available a few years ago. It's a little bit let's say the standard for the digital twin is not fixed yet. I told you that RAMI is fixed, IRRA is fixed, but the digital twin itself, how it really looks like, what kind of data has to be integrated in this digital twin. There's no worldwide standard available right now. They are working on it, and at the Hannover Fair this year, they told us they are pretty close to have a standard, but we as Phoenix Contact have the experience that we want to start a little bit earlier, because it's a very complex topic, and if you wait until a paper, a standardization paper is available, and then you start your work with the digital twin, it's a little bit too late. We think it's important to know about how these communication standards are working, and we know about that because we are in the platform Industry 4.0. And with this knowledge, we started to build up our own Phoenix Contact digital twins. We use them in our production lines, for example. At the moment, we do not make them available to the public. Of course, if you call, our sales guys have the possibility to access the digital twin. Next step may be that when you log into the eShop, you can look online into your digital twins. So what you have bought, you can see also as a digital twin there. Is an idea for maybe earning money. So it's not defined what you will pay for, or is the digital twin something you will get when you buy a Phoenix Contact product. Another thing is who owns the data. So when we offer you a digital twin, it's mainly our information that we offer you. But when you take over the twin and fill it with your information, then of course it's your information. But it's not clarified right now who owns the data, who earns the money with the data. So there we have to wait a little bit, see how it happens. But we started already because for us, we think it's very important to have the data available. So we have the databases available. We know what is happening in the cabinet. So we are building the products, we know about the product itself, about the hardware, and if we know about the process, what the hardware is doing in the process, we are able to do, for example, predictive maintenance. So that is a hot topic for us at the moment. For example, in our own production lines, of course, we want to know about a motor which is getting slower before it stands still, of course. So this is the point we are working on. But I told you that I have an example from building IoT. I think it's important to understand Industry 4.0 is about production, yes, but the ideas behind digital twin, communication standards is the same for all other applications also. So today I think it's interesting for you to have a look into building IoT and what we do there. So I hope this will be a good example to give you some ideas what is possible if you use this digital twin of a product, if you use a digital twin of a building, if you use a digital twin of a combined heat and power unit, for example. And this is what I can describe here. So we started using these digital twins. This is our company located in Bad Pyrmont, where we built this building new 1.5 or 2 years ago now. It was finished, and here we integrated everything what is possible today for us with building IoT. So you have learned what is a cyber-physical system. On the pictures, I've shown you a small product together with this digital twin. That is a cyber-physical system. Of course, you can think of cyber-physical systems as you need it. So also, the whole facility here, or one of the buildings, is a cyber-physical system with a digital twin with a description that I can communicate with. So for us, this building IoT thing was based on digital twins and on cyber-physical systems, on all the topics I told you a few minutes before. So we have different building types here. We have production here and here. And development and office buildings are these. We have maintenance management, so we do predictive maintenance with learning algorithms. We have plant monitoring, so heating, ventilation, air conditioning, also space, everything is monitored. You can see it online. Also access control, security, video surveillance. We have charging infrastructure available, already including with interfaces to billing systems, but they are not online, so at the moment it's for free as far as I know. Energy optimization, so load and storage management, heat and cooling ring over the whole facility, and we have this combined heat power plants, 2 of them. We have heat pumps and photovoltaic. So everything is combined in only one building management system. So we think first step is to make it visible, to understand what is happening. So as we have heard before, applications are growing, networks are changed. So someone plugs something in, takes something out, whatever. So our systems, our buildings are some kind of living. So they are changing all of the time. And therefore, we think we have to have all applications in one software available so that I know what is happening right now. I go into detail with this newest building. So this is the office building. It's around about 80,000 square meters on 5 floors. And it's nearly 600 employees working in this facility there. On the roof is a 160 kilowatt photovoltaic plant, and as I already mentioned, we offer some charging stations there. Most of all, we started with understanding what is available there. So everything, we have it on one system. You see here a colleague, he has it on an iPad. So you have access to this information when you have the address and you are a Phoenix Contact employee. You can access this online software from your computer. We have screens in the facility itself, so you have always the access to all of this information. So it's a web-based system, and our colleagues from facility management connected really all devices. So when we started this new building, it was said that we only buy parts for this building that are able to communicate. So if there's a part that only can communicate with a closed system, which is not open, and we cannot access the system with our controller, we won't buy it. So that was the main focus when we started building up this this building there. So each pump, elevator, solar panel, lights, everything what is integrated there can communicate on an open communication model. So with this, we have a good overview. So we know about energy, we know about trends, what is happening. So we can use this to identify what can be improved. There is, for example, an app, very nice for us working there. So you have an app, you enter a room, and with your mobile, you can change the light, you can handle the temperature in the room, for example, so it makes us very flexible. The system automatically improves energy efficiency. We have heard about that before. So for example, with this system, we are able to cut everything what costs really money. So we use also different kinds of energy optimization. So we produce own energy, and most of all we buy energy. But with this optimization software, we are able to reduce really the costs because we have no peak loads anymore. So we can handle the whole system, the whole Bad Pyrmont facility, very energy efficient. And very interesting was we now can do many things we haven't thought of before. This was a lesson really learned with this project. So where we discovered lots of things that can be improved when we have the overview what is happening. Just to give you an example for this, we have 2 elevators in the middle of the new building, and you have one point where you can order the elevator. You have no, so you cannot order elevator 1 or 2. The controller of the elevator sends the one it prefers, whatever. No one knows why elevator 1 or 2 is coming. It's done by the controller from this elevator company. No one took care about that. But when we had the data from the elevators, we counted them, and we found out that elevator, I don't know, 1 or 2 is coming twice as often as the other. For me as a user, it's not important. I don't care if I took the left or the right one. But it's important when it comes to maintenance, of course, because we have a maintenance interval for each elevator. And of course, we have to pay for it, and we want the people who do the maintenance to come only once. So we detected there is a big difference. For us, it costs money because we have the maintenance guy coming twice, and therefore we now can level this. So now our controller takes over and sends the right elevator so that maintenance can be done for both of the elevators at one time. Of course, these are only 2 elevators. Of course, we have more, but these 2 are already connected to this IoT building thing. Another thing, what we thought about when we installed everything and got the first overview was that our maintenance guys from facility management found out that with this combined heat and power plant, there's always a shutdown because of the fuse. Usually the fuse gets broken on Saturday or Sunday, so someone has to come over and start it up again. But the fuse is the only thing that could break on this combined heat and power unit. So only thing they did, they now monitor the voltage of the fuse. And if there is a small drop in this voltage, they know, okay, it may take maybe 1 or 2 weeks and the fuse will blow. So they now take care about changing the fuses as early as possible. For Phoenix Contact, it's not so important because we only have 2 of those directly on our facility. But when we show this to guys who have from the energy departments from the countryside, they have more decentral combined heat and power units over the whole country. And they are very interested in managing these things with the fuses. So they only have to send one person going around changing fuses, and they know there's no shutdown anymore. So these are only 2 examples to describe what you can do when you first of all have a good impression what is happening in your application. And I think that doesn't matter if it's an application of production lines, if it's from energy or whatever. First of all, collect data, think of what you can do with the data, and nowadays we earn money with this because we sell this software to our customers. So I hope this gives you a good impression about what is possible only by using digital data and to get an overview. Of course, for each one it's different. So each company has different ideas, different customers, different areas of application, but the basis idea is always the same. You have to collect the data, understand what is going on, and then think about how you can use this for your or your customer's advantage. So I hope this gives a good impression. Thanks for your time, listening. I think my time is over now.
Thank you, Anja. That was very